Okay, we're going to look at mean and standard deviation, this time of a frequency table. Okay, now we're going to find the mean and the standard deviation of a frequency table, and we're going to start with an ungrouped frequency table. Okay, we're going to have a look at the mean first. So the mean of a list from before was that, wasn't it? So if we take the frequency table and look at it in terms of the people, these 6 people all said they got a mark of 1. 1, 2, 3, 4, 5, 6. These 5 people all said they got a mark of 2. All right, so it looks a little bit like that. The 7 people all said they got 3. Is that 7? 1, 2, 3, 4, 5, 6, 7. And these 4 people all said they got a mark of 4. So actually what we'd need to do is we'd need to add up all those numbers and divide them by how many people we have. All right, I think we've actually got 22 people. Now, it's much more efficient to actually change the formula. So what I'm going to do is I'm going to make this look like a table, like so. I'm going to call this X, and I'm going to call the number of people F. And in actual fact, instead of me adding up these 6 ones, it would be much more sensible for me to say 1 times 6 is 6. And instead of me adding up these 5 2s, it would be much more sensible to say 2 times 5 is 10. And instead of the 3s, I'm going to say 3 times 7 is 21, and the 4s, 4 times 4 is 16. Now what I've actually created for myself here is a column where I've done X times F. And the way that I want you to remember this, guys, is you're going to remember X factor. All right, XF, X factor. Here he is, the man himself. So in fact, the formula in here is the sum of X. The formula here, let's change the formula. The formula here is the sum of XF. All right, that's what I'm going to do, the sum of XF. So that will be like my total X, the sum of XF, and if I'm correct, that all comes to 53. Now, what we did before is we divided it by the total N. Now, the total N can be found by looking at the sum of the frequencies. And if I add the sum of these frequencies up, I've got 22. So in fact, I'm going to change that bit of the formula to the sum of F. In fact, that's looking a bit messy, isn't it? Let's write it out again. The sum of XF over the sum of F. So it's 53 over 22. And again, we're going to write it all out. It's 2.409090909, which rounds to 2.41 to 3 sig figs. Now, the way I want you guys to remember this formula, because you're going to have to learn this formula off by heart for the mean, is you're going to remember it as X factor is fabulous, or you can think of it in any other F you want. X factor is flippin' marvellous. X factor, fandabby-dozy. X factor, you can think of your own F word. X factor F. All right, okay, so there he is, X factor F. Okay, the standard deviation was found. This is what it was for a list. It was the sum of x squared over n minus the mean squared, all right? That's what it was for a list. So let's have a think what we're going to do. So we're obviously going to start off by squaring the x's. So let's make ourselves a little bit of space. So if we square the x's, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. Now, we did add them all together there when it was a list, but of course, we haven't just got a list, we've got 6 of them, and 5 of them, and 7 of them, and 4 of them. So in actual fact, the formula is going to change, and instead of having x, just the sum of x squared, we're going to have to times them by all of their frequencies. So we're going to have a column here that goes x squared times f. So we're going to go 1 times 6 is 6, 4 times 5 is 20, 9 times 7 is 63, and 16 times 4 is 64. And in fact, we're going to sum x squared times its frequency. So that gives me 153. Can you hear the thunder outside? Now, obviously, that's going to go into my formula here. So 153 over. Now, this is what it was when it was a list. Notice it was an n, but when we're using a frequency table, we're going to use the sum of f instead. So actually, it's going to be a 22 in here, and then we're going to minus the mean squared as normal. And don't forget, we're going to do that mean as an exact value, And if we put all of that into my calculator is giving me 1.072765793, which is coming to 1.0723 sig figs. So I'm just going to squeeze. Let's move this up a bit and see if I can squeeze it. I'm going to get the next question, but it doesn't matter. I want you to write out the formula for the frequency table, standard deviation. It's the sum of, there you go, the sum of x squared f over the sum of f minus the mean squared. And again, gang, you're going to have to learn it, all right? The sum of x squared f over the sum of f minus the mean squared. Okay, so here's a grouped frequency table. Let's make it actually look a little bit like a table. So there we go. So we're going to start off with the mean, and the mean is the sum of x factor over the sum of f. So x factor, flipping marvellous. All right, okay, so x factor f. Here's my x's and here's my f's. Now, the first thing we do is we have a problem because we can't do fx, f times x, because we don't have any numbers for x. So all we do now is we use the midpoint. Now, you're probably fine with this. The midpoint is found. So if I was going to find the midpoint of 0 and 4, I actually add them together. Can you make sure you press equals on your calculator when you do that? So press equals at that point and then divide it, and nothing plus 4 divided by 2 is 2. So in actual fact, I need another little column here for my x's. Nothing add 4 divided by 2 is 2. 5 add 10, press equals and then halve it is 7.5. 11 add 16, press equals, then halve it is 13.5. 17 add 20, press equals, then halve it is 18.5. And 21 plus 30, press equals and halve it is 25.5. Okay, so now I'm going to do my XF column. So 2 times 2 is 4. 4 times 7.5 is 30. 6 times 13.5 is 81. 5 times 18.5 is 92.5. And 5 times 25.5 is 127.5. Now, if we add all of those up, the sum of XF comes to 335. So my formula is 335 divided by the sum of f. Here's the sum of f. Let's squeeze him in here. The sum of f is 22. And 335 divided by 22 is coming out as 15.22727273, which is 15.2 to 3 sig figs. Okay, so let's now do the standard deviation. So the standard deviation is the sum of x squared f over the sum of f minus the mean squared. Okay, so I've got to have an x squared column. My pen's going funny now. My x squared column. Right, 2 squared is 4. 7.5 squared is 56.25. 13.5 squared is 182.25. 18.5 squared is 342.25. 25.5 squared is 650.25. Yuck. Then I'm going to have a column saying x squared times f. So x squared times its frequency is 8. 56.25 times 4 is 225. 182.25 times 6 is 1093.5. This one times this one, 1711.25. And this one times this one, 3251.25. It's crunching. It's horrible, horrible crunching. Okay, so the sum of x squared f is coming to 6289. So we're going to get the square root 6289 over the sum of f. Where's that gone? The sum of f is there, it's 22, minus the mean squared. And we're going to take the mean here, 335 over 22, and it's all squared. And if we put all of that into our calculator, we're getting 7.34804742. And that's coming out as 7.35. Gosh, crunch, crunch. Okay, I suggest you pause the video, have a go, and then I'll float the answers up. Okay, here's the answers for the first one. Did you get that right? Pause it. Yep, 2.14 and 0.990. And then here's the answers to the second one. There we go, that's where they start. Alrighty, fantastic.